The world is turning to green hydrogen as a clean energy source for industries, transportation, and power. But there's one major hurdle. Hydrogen production needs water, and with water scarcity increasing, relying on fresh water isn't sustainable. What if we could use seawater or wastewater instead? In this video, we will explore how seawater and wastewater can be transformed into alternative water sources for hydrogen production and technologies what makes these solutions possible. First, how is green hydrogen produced? The process, called electrolysis, splits water into hydrogen and oxygen using electricity from renewable sources. The problem? It takes about 9 liters of water to produce just 1 kilogram of hydrogen. With freshwater resources already strained, it's crucial to find alternative sources where seawater and wastewater comes into play. But these aren't easy solutions.
Let's start with seawater. It's the most abundant water source on Earth. But the problem? It contains salt, which can damage electrolysis equipment and makes the process inefficient. One solution is desalination. Desalination removes salt and impurities from seawater, making it usable for electrolysis. The most common method is reverse osmosis, where seawater is forced through a membrane that separates out the salt. Another method is thermal distillation, which boils seawater and condenses the vapor to produce clean water. Both processes make seawater viable, but they require a lot of energy themselves. Another exciting development is direct seawater electrolysis. Researchers are working on special electrodes that can handle the salt without needing desalination first. If successful, this could dramatically reduce cost and make seawater a key source for hydrogen production.
Let's turn to wastewater, which comes from households, industry, and agriculture. Although it doesn't have the salt content of seawater, it can be contaminated with organic matter, chemicals, and heavy metals. Depending on the source of the wastewater, filtration, biological treatment, and chemical processes are required. The treated wastewater can then be used for electrolysis, just like fresh water. As wastewater treatment plants already handle large volumes of water, they are ideal for adding electrolysis systems that split water into hydrogen. This integration allows us to recycle water and reduce waste while producing clean energy. While this approach can reduce costs and carbon emissions, it can also be technically and logistically challenging. Wastewater treatment needs energy, and further purification might be required to protect the equipment.
So now, what are the main challenges? First, both desalination and wastewater treatment are energy intensive. To make these processes truly sustainable, they need to be powered by renewable energy, but scaling this up is costly. Second, direct seawater electrolysis, while promising, is still in the research phase. We need more durable materials for the electrodes and more efficient designs before it can become commercially viable. But, despite the challenges, the future looks bright. To conclude, seawater and wastewater offer exciting alternatives for green hydrogen production, but there are significant technical challenges to overcome. Thanks for joining us as we explore the future of green hydrogen. Stay tuned for more updates on the cutting-edge technologies that could power the world with clean energy. Thank you for watching.